All right, let's look at some curve sketching, and I guess I want to define a couple of things first, and then we'll kind of do this bigger problem. So f prime greater than 0, what does that mean? Okay, so if f prime is greater than 0, that means you have a positive derivative. Well, what's a derivative? A derivative is a rate of change. So if you have a positive rate of change, what does a positive derivative mean? It means your function is increasing. So an increasing function, increasing f value, which means the actual function is going up, right? It's got a positive slope. Well, if f prime is less than 0, meaning the derivative is negative, that means your function is decreasing, right? A negative slope, a decreasing. Okay, well, what does a positive second derivative mean? Well, a second derivative is the derivative of the derivative. So if the second derivative is positive, that means you have an increasing slope. Again, you have a positive rate of change of the slope, an increasing slope. And we'll talk about what that means in terms of looking at the graph. And then, of course, a negative second derivative would be a decreasing slope. It's its own rate. It's the rate of the derivative. So a decreasing slope. Okay, so what does it look like in terms of a graph? Well, it's easy to really keep track of. If the first derivative is positive, that means the graph is going up. Okay? If you have a negative derivative, it means the graph is going down. If you have a positive second derivative, that means you have an increasing slope. That means you have to be smiling. Look at this. Anywhere on here, as we move left to right, the slope's getting bigger and bigger and bigger. Now, this one's a little hard sometimes because the slope, well, it's negative here, and then 0, and then positive. But this entire time, the slope is getting bigger and bigger and bigger. And in a decreasing slope, well, that's just what a frown is. Right? So when you think of positive second derivative, you're going to think a nice smile, and you're going to think of a frown for a negative second derivative, because look what happens here. Positive slope, less positive, less positive, less positive, 0, negative, bigger negative, bigger negative. It's always decreasing. Okay, it's going to go from a positive to 0 to a negative. An increasing slope might go from a negative to 0 to positive, but that whole time it's increasing. Okay, so let's draw what these will look like. So let's pretend we know that our function has a positive derivative and a positive second derivative. What does that look like? Well, that means the function's going up, and it's going up and up at an increasing slope. So it'd have to look something like this. Okay, look, the derivative is positive, the slope is positive. The slope's getting bigger because the second derivative is positive. Well, what if we had a positive slope but a negative second derivative, which means our slope is getting less steep, but our function is still increasing? Well, that'd be looking like something like this. Okay, you can see this is like half of a smile, and this is half of a frown. Both of these things are increasing. One's increasing at an increasing rate, and one's increasing but at a decreasing rate. The slope itself is getting smaller. Okay, and then these are just the opposites. This is a negative derivative, so the function's decreasing, but the slope is getting bigger, so it'd be something like this. The function's always going down, but it's going down at a smaller and smaller rate. Okay, the slope is increasing, right? Going from a negative to even less negative to almost 0. And here the function's going down, but the second derivative is less than 0. So the slope is getting more and more and more negative. So draw something that's down, and a slope that's getting worse and worse and worse. Again, see these positives are both smiles. These are both frowns. This is just it's going up and it's frowning, and this is it's going down and it's frowning. Okay, so this is a ton of information, but we're going to sketch the graph based on this information. Okay, do need to make one change. That didn't mean to be the second derivative right there. That's just f prime. Okay, so what we know here is that these are our maxes and mins. All right, those are our maxes and mins. That's where the derivative is equaling to 0, and where the derivative is equal to second derivative, or the second derivative is equal to 0, those are our inflection points. We do have to make sure that they actually have a change in sign, but they will in this particular problem. So we want to just kind of sketch this. So let's look at what's happening here. the function is going to be going down from negative infinity to 2. Then it's going to be going up from 2 to 10. Then down from 10 to 15. And then up from 15 to infinity. And that makes these make sense. If you draw a sign chart here, we can look at it on a sign chart, and we have 3 zeros, 2, 10, and 15. And what we know is that the derivative is negative there, then positive, then negative, and then positive. So our function is going to come down, and then go up, and then go down, and then go up. Something like that. So this is some minimum at 2, maximum, and then minimum. And this is me looking at the derivative. Okay, let's look at the second derivative. The second derivative is 0 twice at 5 and 12. Okay, the second derivative is negative between 5 and 12. That's there. The second derivative is positive here and here. Again, this is the second derivative. So I'm smiling, and then frowning, and then I'm smiling. So that's what it kind of has to look like. And so it's going to go down and hit some minimum, and then go up, and this is at 2, and this is at 5. And then before it gets to the maximum being at 10, it's already went from a smile to a frown, and then it's going to go back down, and then at 12, it's going to turn back into a smile, and then at 15, it's going to hit the bottom and then go back up. Again, let's think about this. It's going to go down with a positive second derivative, hit 2, and then go back up, and at 5, it's going to change to a negative second derivative, and it's going to go back up, and it's going to frown, and it's going to maximize at 10, and then it's going to go down at 10. At 12, it's going to change back to a smile. It's going to hit 15 and go back up. Okay, so it's going to look something like that. This is 2. This is our 10. And this is 15. And then our points of inflection, meaning or points where it changes concavity, it's going to change at 5. Right about there. It goes from smiling to frowning. And then once it gets to 12, somewhere right there, this is 5 and this is 12, it goes back to a smile. Again, make sure it matches everything. Mins and maxes are where the derivative is equal to 0. Changes in concavity are when the second derivative is equal to 0. It goes down and then up and then down and then up. Down, up to 10, down to 15, and then up. Okay, it matches this. Second derivative, it's smiling, meaning it's got a positive second derivative. It's concave up here. And then at 5, it switches to concave down all the way to 12. And then from 12 to infinity, it switches back and goes to a smile. So given this information, you should be able to produce some sort of graph that looks like this, or whether it's on a grid. You don't really know the y values, but you do know that particular things happen at those x values based on this information. And I would argue that if you know the basics, what does it mean to have a positive derivative? What does it mean to have a negative second derivative? Like these ideas, then you can put them together what the graph must look like if you know those informations. And then you just got to kind of slowly do this. I think going from here to a sign chart kind of makes sense, and then going to a graph. But hopefully this is going to help you sketch some curves in your future. But again, always go back to the definition of what does it mean if you have these 4 things.